Hi. So in this presentation, I'll be walking you through the concept of stubs and mocks and how we used EasyMock in our project to implement unit testing. So let's start with the basics. Mocking is a way to simulate objects or components during testing. The goal is to isolate the code under test by replacing its real dependencies with fake ones. And this helps us test faster and more reliably, especially when real dependencies are unavailable, slow, or complicated to set up. So, to mock something, we use what's called test doubles. These are fake objects that stands in for real ones during testing. There are five main types that are dummies, stubs, spies, mocks, and fakes. So dummies, which are just placeholders and never used. Stubs, which provide predefined responses. Spies, which record how they're used. Mocks, which simulates behavior and checks for expected interactions. And fakes, which are working but simplified version of real implementation. So, why use EasyMock? It's a simple yet powerful mocking tool that integrates seamlessly with JUnit. So it lets us isolate code, avoiding real dependencies like APIs or databases, define expected behavior using expect, activate mocks with reply, and finally verify outcomes using assertions. It also improves test reliabilities by removing external failure and making tests faster and easier to debug. EasyMock supports useful features like annotation-based mocking with @mock and @test_subject, auto-mock creation, support for strict vs nice mocks, and verification of method calls and parameters. So, to set it up, I made sure that JDK 1.8 and JUnit 4 were installed. Then I downloaded and added EasyMock jar file as a dependency in IntelliJ under the project structure. Everything was set up manually without editing the source code. So I just linked the correct libraries. Now, for running the test with the EasyMock, here's an example where with EasyMock, where I tested the math application.add method using mocked calculator service. So we defined the behavior with EasyMock.expect, activated the mock with reply, and verified the result using assert equals. So the test passed successfully, which confirmed that our mock returned the expected value and the test logic worked as intended. So that wraps up my part. We saw how mocking helps us test in isolation and why EasyMock is a great tool for the job and how to get it working in a Java project. Now I'll hand it off to my teammate to walk you through the code base we did and the test case design. Thank you.
I'm Fida, and in this part of the video I will introduce the code base we choose to test using EasyMock and walk you through the design of our test cases. Our project simulates a simple payment system. It has two main components, a class called payment processor, which contain a logic to handle payment, and also we have an interface service, which represent an external dependency, for example a connection to a real banking system. The class that we are actually testing is the payment processor. It's depend on the banking service to make interface to make the transfer, but it doesn't care how the bank service work. It just call the method. This method process payment. It handles three things or does the three things. If the amount is invalid, less than or equal to 0, it retain an invalid amount. If the amount is valid, if the amount is valid, so it will call bank service data transfer and send the account ID and the amount. If the transfer is successfully, it will retain a payment successfully. If not, it will retain payment failed. Why we are using a mock? In our case, the banking service interface doesn't have any implementation, and that intention. Instead of writing a real bank service that connect, for example, to the API to the bank API or the database, we use the EasyMock to simulate it. With EasyMock, we can define a transfer method should retain a transfer what this method should retain, so we can focus on testing just the logic inside the payment, the process payment. Now
And I will be showing how we implemented and run our test cases using EasyMock and what the results looked like. So first of all, for implementing the tests, we wrote our test cases in the file called paymentprocessortest.java, and inside of this file we used EasyMock annotations like @mock and @testSubject to set up the testing environment. We also used 3 test methods, each representing a different scenario. So for test case 1, in this first test, we used EasyMock to create a mock of bank service. And we set an expectation that when the method transfer account 123-200 is called, it should return true. And then we activated the mock using the .reply and called the real method from payment processor. We used assert equal to check that the return value was payment successful as expected. And this concludes the first test case. In test case 2, we changed the mock to return false for the same transfer call, and this simulates a failed bank transfer, and the method should return payment failed, and we are asserting this with an assert equal method as well. And this concludes the second test case. And for the third and last test case, we are testing the invalid amount. So the third test passed a negative amount to the process payment, which is -50. And in this case, this test case will run without even calling the mock. And that's because we have an if statement inside our production method, and this if statement will return an invalid amount without even executing the transfer method that need to be simulated with an EasyMock. And this concludes the third and last test case. So for running the tests, we run the test class using the IntelliJ built-in runner from here. And we can see that all 3 of our tests passed successfully. So in summary, EasyMock helped us simulate the behavior of bank service without writing any real implementations, which allowed us to focus only on the logic inside the payment processor and test it under multiple conditions in a clean and controlled and isolated way. So this concludes our demonstration for this assignment, and thank you for watching.